Shadow is a kind of unique group of engineers who came together over 20 years ago to try and build useful robot technologies. We're best known for building hands for robots, but we do a wide range of work around next generation robotics, making new robots happen for people. For the PAN technology, our main customers are people doing research in robotics, trying to work out how to make robots perform better, do better tasks in the world. If robots are going to do complex human-like manipulation, there's a huge amount of understanding of the way humans do manipulation that has to be done first. Our original robot hands were built using pneumatic actuation, air muscles. With antagonistic air muscles you can get very good biological performance, but it carries a high cost in terms of needing a compressor and lots of valves. In 2006 we got some funding from the European Space Agency and the Ministry of Defence to build a next generation hand which was electrically actuated. And so we spent quite a long time looking to try and find an electric actuator that would give us the kind of performance we were seeing with the pneumatic actuation system. And across the board, the only people who could deliver the kind of power we were looking for in the size we needed were Maxim. When we developed the Shadow hand, we strove to make it as close as possible to the human hand. So there are many gripping and grasping tools that have 1 or 2 or 3 actuators, and they're great if all you want to do is to pick up a certain class of objects. But as soon as you want to do something a little bit more complex, maybe you want to adjust the object or change the orientation or adapt to a range of objects with perhaps slightly difficult grasping features, you need something with human-like dexterity, and so that's where we've pushed the boundary forwards. The motor in the hand is used to drive the joint rotation forwards and backwards. So each finger joint there has a corresponding motor in the base that moves it. And we have a drive arrangement we put together that allows us to sense the tendon forces there to get compliant movement. Traditionally, motor systems, it's very hard to get compliance. With this arrangement, we found it very easy. We're looking at a number of future markets for the hand technology. These range from offshore use, where you could replace a diver with human-like manipulation controlled remotely, increasing safety and speed of operations, right the way through to agri-tech, where picking of fruit and vegetables consumes a huge amount of human labour and yet doesn't really require the full might of the human brain. So we found working with Maxim to be a great experience. They're a responsive company, they're very technically minded, they solve hard problems in their own space. And for us it's great to be able to rely on someone to solve their problems so that you can get on and solve your problems.